Problem description. A right triangle with a hypotenuse of length 1 is inscribed in a square of side A as shown in the figure. The vertex of the right angle is also the midpoint of the square's right side. Find the area of the inscribed triangle. The right side is split in half, so each segment has a length of A over 2. The bottom right triangle has legs of A for the base and A over 2 for the height, which gives a 2-to-1 ratio. Due to the green right angle, the top right triangle is similar to the bottom one, sharing the same 2-to-1 ratio. Since its height is A over 2, its base, which is the top right segment, must be half of that, which is A over 4. Therefore, the remaining top left segment is A minus A over 4, which equals 3A over 4. The top left-right triangle has legs A and 3A over 4 and a hypotenuse of 1. According to the Pythagorean theorem, we have A squared plus 3A over 4 squared equals 1 squared. Solving this equation, we conclude that A equals 0.8 units. Shaded area. Subtraction method. With all segment lengths known, we can now easily calculate the area of the square and each of the 3 right triangles. Therefore, the area of the shaded triangle is the area of the square minus the sum of the 3 surrounding areas. This simplifies to 16 over 25 minus 11 over 25, giving a final answer of 0.2 or 1/5 square units.